Good morning, everybody. It is Monday. Thanksgiving is just right around the corner. Hey, we're going to have some days off. We're going to get at least 4 days off. Well, 4.5 if you add the half on Wednesday. So anyway, today, 11:23. And again, we're talking about exponents, but today we're talking about exponential functions. So this whole chapter's been about exponents. And today specifically, we're going to talk about exponential functions. Okay, the graphs and the equations. So let's start right off here with the standard form. F of x equals a b to the x, and it's called exponential because, of course, the exponent's the x, right? That's why it's called exponential. Or y equals a b to the x. Same thing, right? F of x and y are the same thing. Now, here's what we know. Here's exactly what we know. We know the a is going to be like the y-intercept, or the beginning amount. And the b is the base, or the rate. Okay, let's write those other words down. Okay, it's like a y-intercept. Because if x equals 0, anything to 0 power is 1, and you get a, okay? And this is the base, or the rate. Okay, when I say rate, something's doubling, or if it's growing by like any particular percentage rate, that's the rate, okay? So number one, it says graph and determine what type of function this is. So one of the things we do know, and real quickly, we've seen this, that exponential functions look like this. I'm just going to make a real rough sketch of what they look like, okay? So exponential functions, if it's growth, they look like this. They have that almost like a J shape, but exponential growth looks like that. And then, again, we've also seen just the opposite. If it looks like this, it's exponential decay, but it's still exponential. Okay, this is growth. This is going to be growth, exponential growth, and this is going to be decay, exponential decay. All right, so if I took a look at question number one, and I want to graph it. So, it looks like I have to go all the way up to 81, so I'll make sure my y values probably go by 10. Probably make my y values go by 10. I can kind of see it is exponential. But let's graph it anyway, huh? Let's just graph it anyway. Alright, so if I put my graph down like this, and probably we can go 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to go 10, 20, 30, 40, 50, 60, 70, and of course 80. Okay, so if I were to graph this, then what I would have is the following. So I'd have 1 and 81, which is about there. 3 and 27 is about there. 5 and 9 is maybe there. 9 and 1 is there. So it sure does look like, 7 and 3, I missed one. It sure looks to me like it's exponential, okay? But it's exponential decay, and it sure looks like what we're doing is we're going and we're divide by 3, divide by 3, divide by 3, okay? So we could determine what type of function it is. Definitely exponential decay. Probably y equals 81 to the 1/3 to the 2x. It's probably my guess what the equation is, but we don't have to come up with the equation yet. But that's kind of my guess, okay? Plug in 1, plug in 2, plug in 3, okay? Now let's look at number 2. Number 2, let's go ahead and graph that. That does not, I think this one's going to maybe be quadratic, or it's going to look like quadratic. But let's put it down and check it out, okay? So all we have to do is just look at the graph. All we're looking for is the shape. We don't really even need the equation. I'm not sure if I even had the right equation for that last one, but let's go ahead and take a look at it, okay? Alright, so I'm going to graph down, I'm going to graph this, and the values I'm looking for are at, let's see, let's put down my 1, 2, 3, okay, so I'm going to go 1, 2, 3, 4, 5, 6, 7, right? And then I can go by ones on this one also, right? 2, 3, 4, 5, 6, 7. Okay, so pretty easy. I'm going to have a point at 1, 3, boom, 2, 1, boom, 3, 1, boom, 4, 3, right about there, boom, and then 5, 7. All right, so to me, this doesn't look like either one of these, right? No. It might, if I were to go ahead and connect it, it might be quadratic. That'd be my guess, is quadratic. There we go. That'd be my guess. Okay. All right, now, swoop this away. Quadratic, so this one was exponential decay. This was probably quadratic. Looked like a x squared to me. Exponential decay for sure. Quadratic. Now, number 3. Yeah, it is number 2. It says find the exponential function from these points. Okay, so let's take a look. So if we graphed it, it doesn't really give us enough information if we graph it. 1, 2, 5, 6, 1, 6, and 2, 12. You know, it's just not enough information to get it. But what we can do is exponential function. Let's see. I think we've got an exponential function right up here. Right? So let's write y equals ab to the x. Okay, this is how it works. I know you can do this. Watch. Every point has some x and y value. So if I take my 6 and put it in for y, exponential function, put my 1 in for x, let's see what we get. So I'm going to rewrite this as 6 equals a b to the 1 power. Okay, so I just merely put in my 6 in for y and my 1 in for x. Now, too many variables. So now what do I do? Well, let's try the other point. So again, y equals a b to the x. So what I'm going to do is this. I'm going to plug in this point also into the equation. I'll plug the 12 in for y. I'll plug the 2 in for x. Now, here's what I've got to do. I've got two different equations. I've got two variables. So if I solve, let's solve for possibly a. Solve for a. Watch what happens, okay? Divide by b, and I've got 6 over b equals a, okay? And then what I'm going to do is this. I'm going to put this 6 over b in here for a. So I'm going to substitute, okay? So instead of writing a, I'm going to write 6 over b. Alright, come back. Music popped on. So then, let's see what I do. I'm going to take this, solve for a. I got 6 over b, put that in for here. So let's go 12 equals, not a, but what a equals. I'm doing a substitution. 6 over b, that's what the value of a is, times b squared. So what did I do? I had two equations. I plugged in the points into both equations. I solved for a, so I get to substitute over here. And now solving is going to be pretty easy. I'm going to have 12 equals 6 over, well, let's see, b and b squared, right, is just 6b. Okay, and then divide by 6, divide by 6, and I get b is equal to 2. Now, if b is 2, I can then go back over here and substitute that in for this one. So it's substitution twice, okay? So then I've got 6 over 2 equals a, or a equals 3. Now, if I want to find the exponential equation, all right, let's go back to our exponential equation, exponential function, okay? So I know a and I know b, so my answer is going to be f of x, because it's a function, equals a, and we know what a is. A is 3, and we know what b is, times 2 to the x power. That's my exponential function. Okay, it starts at 3 and it doubles. Do not multiply these. Do not. That's not 6. Don't do that, okay? All right, shift the page. Let's look at the next one, okay? So the next one, okay, so we find the equation of these exponential functions. Well, same thing. It's just going to be a little bit more difficult, but I have a calculator. I can do it. Same thing. So again, we're going to start with two equations. Y equals ab to the x, and again, y equals ab to the x. We need to start with, because we've got 2 points, we're going to start with two equations. So I'm going to put 3.6 x and y. My 3.6 in for y equals a b to the 2 power. And then I'll do the same thing here. I'm going to put in my x and y. I'll put my 777.6 equals ab to the 5th power, okay? All right, now, what am I going to do? Well, let's solve for a again. Okay, solve for a. Again, solve for a, just like we did before. Solve for a. All right, let's do that. So I'm going to divide by b squared. All right, divide by b squared. Divide by b squared, so I get 3.6 over b squared equals a. Okay, cool. Now, take this and plug it in for a, because that's what a is, okay? So I've got 777.6 equals a. Well, not a anymore, but what a is equal to, 3.6, my bad. 3.6 over b squared, sorry about the sloppiness, times b to the 5th power, okay? All right. So what happens? Well, let's see. 2 of these will cancel with 2 of these. I'll be left with b to the 3rd, so I'll have 777.6 equals 3.6 b to the 3rd. All right, now I might need my calculator because I got to solve for b. So solve for b. If I solve for b, I'm going to go ahead and divide by, solve 3.6, divide by 3.6. Okay, so calculator time, what is 777.6 divided by 3.6? I don't know. Oh, it's 216 equals b to the 3rd power. Keep solving for b. Cube root, right? Opposite of b cubed is cube root of both sides, and the cube root of 216, believe it or not, is 6. Okay, so b is 6. Awesome. Now let's find out what a is. So take my 6, plug it right in there. Okay, so then I've got my 3.6 divided by 6 squared. That's a 3.6 divided by 36, which should probably be 0.1. What do you think, huh? 0.1. And that's the value of a. Okay, so my equation is this. Here's my equation. I've got a y equals a, which is 0.1, times b, which is 6, to the x power, okay, or f of x. Either way, right? All right, that's my function. Okay, good. I found my function. Now what am I going to do? Well, it says f of 4. Well, I can just plug in 4. So using my equation, let's take 4 and plug 4 into my equation. All right, so I'm going to go, all right, I can do this. I can go y equals 0.1 times 6 to the 4th power, because I'm going to plug in 4, because that's what that says, f of 4. And I'm just going to use my calculator. So I'm going to go, okay, 0.1. Let's see if you can see that. Yeah, you can see that. Okay, so clear. I'm going to go 0.1 times 6 to the power of 4, and I get an answer of 129.6. 129.6. Okay, so homework will be out there for you. I'd like you to get it done before Thanksgiving so that you can enjoy Thanksgiving.